I resume this, pardon in progress. Okay. Or I will be recording to cloud. So, okay, I see. So I see what happened last time. My recording is going to cloud, while Mr. Moses' recording is going to local to his own local system. And I don't have access to the cloud, so Mr. Moses has access to the cloud. Okay. Because I was surprised when I couldn't see my recording last time. So I just saw something on that. My recording goes to cloud. Why can't I record to my local system? Anyways, just continue. All right. So we're going to continue from where we stopped last class. A quick recap of what we did last time. We were able to provision a server in AWS platform. We configured the server, the EC2 server as a Jenkins server by installing Jenkins on the server on the virtual machine. And then we're able to use the installed Jenkins to automate the building and the building of our application and the eventual making of Docker image. We are able to make Docker fast. As a matter of fact, we made 2 Docker images. One for the front end part of the application, and the other for the backend part of the application. And as an evidence of what we did last time, if I go to the AWS ECR, the Elastic Container Registry, you can see that I have the repository we worked on February 13. So we call the repo DevOps backend DevOps. But you can even check the GitHub account. This the DevOps challenge and the Jenkins file that we used to automate the building of those backend and front-end application is this. On right, and this. No, not this one. What did we call the name of the old repository? Let me see. DevOps challenge. I think it's this is not this. It's 5 days ago. Oh, yeah, day of challenge it should be tomorrow. Yeah, I think uh, 5 days ago, 13. This is the repo we used. Was it this? No, I'm having two Jenkins here. Let me forget. You can imagine I've forgotten the repo we used last. Where can I get the clue to that? Okay. I don't know. Let's see. Okay. Let me use this. Okay. This copy link. Okay. DevOps code challenge. That's what we use. DevOps code challenge. So this is DevOps. Okay, challenge. Okay, Q DevOps code challenge. Okay. So, oh, this is actually the one. So why did I think it's not the one for this? Okay, good. So we have the Jenkins file here. And if we look at the Jenkins file, we call our front end DevOps front end, our backend DevOps backend. So this is the DevOps front end and backend. And if we look at the image build file, the image tag that was successful. So that's where we stopped. That's just a quick recap of what we did last time. So the concluding part of the project is now creating the infrastructure needed to run these images as containers. And we are going to use Terraform as the infrastructure as code tool, the tool that to use to provision those resources. Quickly, if we go to, I think, let me quickly check that. Okay, let me open the folder. Yeah, let me open this. There was one. The the uh the document what is it here? The document I shared about that has the architectural design of the infrastructure. Why not? Okay. It's, at least, yeah, this one. Yeah. So the high level, this is the high level, this is the architectural design that we are trying to implement now. to implement to run our images. So we're from this architectural design, as we can see, we're going to have the VPC, create our own custom VPC, and inside the custom VPC, we're going to have public subnet and private subnet. In our public subnet, we'll have a NAT gateway and an application load balancer in the public subnet. And in the private subnet, that is where our AWS Fargate will reside. AWS Fargate is a serverless service in AWS that will not involve spinning EC2 to run our containers. Instead, we'll be leveraging the ability of Fargate to create containers for us. Fargate will do that for us, so we won't have to manage, we won't have to go to spin up an EC2, now install Docker on EC2, then Docker will now start creating containers. So no, Fargate will handle all those stuff for us without our knowledge. All we will just see is containers are running. So that's the beauty of using Fargate. This is serverless. It doesn't require any EC2 on a server for containers. And the Elastic Network Interface is part of the Fargate configuration. So in short, the private subnet contains only the Fargate. And as you can see, the VPC has an internet gateway with it. So that is all we are creating. Very simple architecture, very simple architecture. Okay, and I thank God we won't be perambulating or rigmaroling too much. We have the script for our Terraform resources. So what we'll just do is copy the script and edit and do some little explanation just to understand what you want. So what I will do now is I will open our environment, our terminal to use them in a new window, our VS Code terminal that we'll be using. And remember last section, we created a folder on the desktop where we were able to use our key pair to SSH into. So we're still going to be using that folder. So I'm going to open that folder, please, desktop. Remember, and I call it I think lightweight on the 13 here. So that's the date. Lightweight. I'm going to select open folder, desktop, lightweight, select. So this is a folder. Yes. Oh, okay. Good, I see. Have an extension. Okay, I remember this is where we stop. I ran a history command of all the commands we used. Okay, let me clear this screen. Clear. So we can see the key pair we used to access it into this terminal and the command text. So now I'm just going to create, let me just create a file for our Terraform script. So let me just call it, what should we call it? Give it a enemy light feather .tf. I'm going to call it light feather .tf. So light feather .tf. So I'll go now, copy the script. It's part of the zip folder I sent. So if we look at it, we'll see that there is a Terraform 1 container and Terraform 2 container, because each of them, they are separate. You know, there's the one for one container is used in the situation where we created one image for both our front end and back end. You know, but we have established that that is not good for production. In fact, the whole essence of using containers to run application is for one container to run one application. It's not advisable to model up more than one container, more than one application inside one container. You know, according to what we found out online, that it should be one container, one application per one container. You know, because if we do that, then it will be scalable. That and what they mean by that is that we can decide to want to change some things about that application, then it will be easy for us to change some things about the application. For example, if there's many users and we want to make the application to accommodate the many users that will be accessing the application, we can, you know, quickly edit certain things if the application is running in a container. But in a situation where we have two applications running in one container, it might be kind of difficult to edit one application without affecting the second one that we have tied to it. So that's the whole essence. So we're going to use the one with two container because we have two images. We didn't model we didn't model model the two up together. So we have been able to create them separately into two images. So we use the one with two container. I think I made a mistake here. Let me correct the mistake I made. Let me do this in the naming. Let me do this. Let me change. This one is actually the two containers. I will show you the reason why one is the two container, and it's evident in the script. We will know that this one is for two container, so this one is for one container. So okay, let me open the one for two container and copy the code. Okay, so I will select Control A, Control C. So I've selected the one. Then let's paste the Control V. All right. So let's look at the script real quick and edit and kind of understand what we are doing. All right. Okay. You'll see that instead of dividing this script into provider.tf, I kind of just want to run everything inside one file because just to save time. And this is just a training. When in real life, to make it, in production, to make it really easy to edit, it's better we copy this part from here to here into another file and call it the provider.tf. Okay, in fact, I can even do this. Let me do this. You can call this let's say, yeah, let's use comments to kind of separate it. Number one, can do provider, okay, we can see provider resources, you know, that kind of separation. So then this one would be like this one is our main .tf. So I will just say, so I'm using this what's it called, the slash to separate them, like as if we are separating them into different files. So this one we can say, okay, this is another one. We can call this one number two. Number two, this would be like our main resource, you know, like our main.tf, while these are provider.tf file. So main resources, that's our number two. So, okay, as we can see, we have Terraform required provider, we know all this. And I'm commenting out the secret key. There's no secret key here, so we're going to put it in the terminal instead of making it public. So there's no need of adding this, we can comment it out, okay? So we're going to run AWS configure and put our access key and secret access key on the terminal here, instead of making it visible to everybody. So that's the reason why I just commented that out. Okay, so going forward, this, I think we have seen this script before, but let me just go over it again. You know, during our training, whenever we wanted to create VPC and submit, especially during submit, VPC is okay. VPC template is kind of easy. We just need a CIDR block and tag. That's all. But creating subnet, we need availability zones. And the way we did it while we were doing training is that we hard coded the availability zone. Like we must know it. It's like we had to know it offhand. Like, okay, and the availability zone in region 1 is 1A US East, 1A US East, 1B. I mean, that means we must memorize it. But in the real sense, in the real world, imagine if we are asked to create a resources in Asia, a region in Asia that we are not familiar with, like US East 1 and East 2. How do we know the availability zone in that region? You know, so that means we need to go to AWS and management console and start looking. I mean, it looks like it's not looking professional. So the reason why we are using data will make us use any availability zone, even when we don't know the availability zone. We're not expected to know the availability zone. So the reason why we are using data availability zone, we look for, when we put the state available, we look for all available availability zone in the region we are trying to provision in US East 2. Any region, we can put any region there, we look for the available availability zone in that region. Okay, going forward, we want to create a VPC with CIDR 10.32.0.0 CIDR 16 as indicated in our architectural design. See 10.32.0.0 CIDR 16. Okay, so we have created that VPC. Okay. And then the next thing is to create a public subnet, AWS subnet, and we are using this resource, this template to create our subnet. The availability zone. You see, if it were to be the way we were trained, at this availability zone parameter, we'll be putting US dot east, US hyphen east hyphen 1A. But in a situation where we don't know the US East 1A, whether it is 1A or 1C or 1D, we use this data dot AWS underscore availability zone dot availability zones or whatever reference name we put here. With the count index. The count index is to give us flexibility, like, okay, in a situation where there are more availability zones, just create 2 subnets from those availability zones, from just 2 of them, from 2 availability zones that you have in that region, create subnets. So this we choose from the availability zones that we have in the region. The count, remember, the index of the count start from 0. Computer starts counting from 0, 0, 1. So if we have count 2 here, we say, okay, do 2 counts. Then to start from 0, that will be count 1, then 1 will be count 2. So here it will be changing the count index 0, count index 1. So to get the availability. So to get the availability. So that's just pretty much it. The same thing here. For the private tool, that's okay. Let me make something a bit clear here. Especially about this availability zone. The availability zone we are using here, like I said, if you have count 2, what is the index of count 2? The index of count 2 is 1. Because when we have 2 counts, the count of 2 means we have 2 items, right? And the first item, the index of the first item, index in coding in computer start from 0. So when we have 2 items, 2 counts, the first count we have index of 0, and it is rare from experience to have availability zone with 0 number here. So you see that it starts from 1, then you have the alphabet. So the count here is using 2, that is here, and the index of 2 is 1. So that's the reason why this US East 1 is kind of replacing everything here. That's just the whole essence here. So the same thing here too. The count is 2 here. The count is 2 here. So the index we are creating here will look like this. So this one should actually be E east 2 with whatever alphabet. We don't know what the alphabet is. It will get the alphabet from this availability, the data availability. So it will be A or B or C. So it will ES2 maybe A or B or whatever. So this one too will be ES. The 2 here is the region, but the A here is talking about the index, so the next one will be something like US East to, whatever alphabet that is available, maybe 2B, based on the availability. Zone. Okay, so that's that, and every other thing is pretty good. The template is kind of straightforward. This resource is for the gateway, and of course, you need the gateway, the internet gateway. So we need that. So this creates the internet gateway, and then we have the route. Okay, yeah, there's something I will explain here. I want to show us that I found out that is very important. I'll come back to this AWS route, and we created Elastic IP. The Elastic IP we attach to the NAT gateway, and okay, hold on. Let me even show. Let's go to the Terraform script, the Terraform documentation to see Terraform. Yeah. Let's go here. Look for one of these resources, like the subnet. Yeah. Let's look for the subnet. Oh, yeah. Okay. The subnet real quick. Subnet resource. Then that be AWS subnet here, and that be PC. If you click on it, you see the templates for the resource. You need a CIDR block. This is kind of a basic usage, but we have to specify the availability zone where we are creating the subnet. This is the availability zone ID. So this is kind of optional. The claim is optional. So yeah, trying to see the count parameter. Yeah, but it's not here. The count parameter is not. Okay. it's not here. Then another thing that can help us understand that is this guy. Okay, good. Let me do this. Yeah. So this thing, yeah, this resource, let me copy this resource, copy and paste here real quick. So paste, then let me do on this chat GPT to give us um, the meaning of the script. Okay. That's it. So it says this is a Terraform conversion code that create two AWS subnets in a VPC to public IP. So the count, okay, the count indicates that two instances of these resources will be created. Two instances of the resources will be created. The first instance of the resource, we have a side up this. And the second one, we have a side up this. Yeah. Okay. So overall, this could create two subnets with public IP addresses in the specified VPC. Okay, so that's what the code is doing. It actually creates two subnets with this uh, uh, CIDR blocks, 2.2 and 3 CIDR block. Okay, good. So if we look at it, 3.2 and 3 CIDR block. Oh, okay. They made use of this account here too. And then you remember I told us about this CIDR subnet function. It's kind of good copy that we use it. I mean, we understand what it does. It's there on the internet. It has this net number, this CIDR subnet function. So yeah, it has the prefix, the new bit, and the net num. So this function is used in creating, our CIDR block, different CIDR based on the value you give to the net num and the new bit. This prefix is gotten from the VPC CIDR block. So you compare this function like this to what we have here, you see that this part is the prefix, this is the new bit, and this part is the net num. So that's how we created the CIDR block for the subnet. Okay, so we have this, we have the subnet, we have the internet gateway, we have the route, the AWS route. I'll come back to this We have the gateway, create two gateways, not gateway. I mean, this one is to create two elastic IP. This is for NAT gateway, and this is for our another route. We create a route table for, we call it a private route table that we associate with our private subnet. As we were told during the training, when a subnet is created, all subnets are created as private subnets. Any subnet we create is private. What makes a particular subnet public is by associating an internet route table to the subnet. When we associate a route table that has internet gateway, the route table contains internet gateway, and we associate that route table to a particular subnet, then that subnet turns to public subnet because of the presence of internet gateway. Internet gateway is another name for it, is like saying internet route. And the internet, for what internet means public, anybody in the internet. So that makes that subnet a public subnet. So any other subnet that does not have a route table containing internet gateway, that subnet will remain a private subnet that it is by default. So that's that. So now look at this. There's a route table association with our you can say our private subnet. So we associated a route table with our private. What's the route table doing? This is a route table. The route table is just connecting a NAT gateway. What's the essence of NAT gateway? NAT gateway is to direct traffic between our private subnet to our public subnet. So without a route table, without the NAT gateway, our private subnet might not be able to communicate with our public subnet because they are kind of isolated, like that. So it is this NAT gateway that is making them communicate. The private can send information to the public through the NAT gateway. Then the NAT gateway sends it out through the internet gateway to anywhere the person wants it. The person is accessing the information. Okay, so that's that. Then the association. Then we need a load balancer. As we can see in the diagram, there's a load balancer. And a load balancer, application load balancer, ALB, needs security group to control its traffic. As a matter of fact, there are two other resources that are created when a load balancer is created. We don't just create a load balancer alone. There are two other resources. But with the security group, it makes it 3 resources that must go with a load balancer. When we create a load balancer, there's a resource for load balancer itself. After creating a load balancer, then we'll create something called load balancer listener. That's another resource that goes with load balancer. After creating load balancer listener, we'll see it here. This is a load balancer, AWS_LD load balancer. So this resource, you can see the template, it's a very small template, the name, the subnet you are creating the load balancer in. So you can see it's in the public subnet, and the security group that you are attaching to the load balancer that will control the traffic that goes into the load balancer and the traffic that goes out. So just these three parameters are there. But whenever we create a load balancer, it's a must, we must create a target group. A target group, we call it load balancer target group. After load balancer target group, there's a load balancer listening. See, this goes with the load balancer, and of course, the load balance is security. So it's like a load balancer requires like 1, 2, 3 additional resources to make it whole, to make it a full resource. So we must put that at the back of our mind that, okay, whenever we are using a load balancer in an application, there is need to create a target group, there is need to create a listener. We understand what each of these resources do to load balance. Of course, we know what a security group does. So what is a load balancer listener? A load balancer listener is just like, as you can see, it only has few parameters in it. And what it does is just to listen to request, because it is the load balancer that interfaces with the internet. So the load balancer must have a port that is open, like a door here, that is open for requests to come in. So, and you don't want your load balancer to just open any door or all its doors. You want to safeguard your load balancer so that not just anybody can come in. You just open a particular door that you have told someone on the internet, say, hey, if you want to enter through my load balancer, this is the door you go in. Every other doors are closed. So that's what the listener is doing. The listener will open a particular port and be listening for the person that you have told on the internet that, hey, whenever I hear you coming, I open the door is open, so you can come in with your request, and I will direct your request or forward your request to wherever it's supposed to go to. So that is what the listener is doing. The listener listening at a particular port. We can change this port to any port, any number. It will listen at that and to forward the request to the target group. So now ask, okay, what is the target group? Target group is the destination where the request that is coming from the outside is going. And where is the destination? The destination is a port to, it's a door. What actually means a door? A door to whether an EC2, a server, or in our case, a Fargate. We are not using server, we're using a serverless Fargate function, a Fargate service. So it will go to a group, a target, as the name implies, target group. So you can add more than one thing to this group. But what we are adding to this group is only Fargate. So we'll be attaching Fargate to this group so that when a listener listens to an incoming request, it will forward it to the target group. And when it gets to the target group will now be, okay, who is a member of this group? It will now check okay, there's a target that has been attached to this group. The target group, the request will be forwarded to target. If it's an instance, an EC2 instance that is attached to this group, the request will be forwarded to the EC2 instance. Let's say let's say in this group we have 2 different targets and 3 different EC2 instances. The request that is coming through the listener will be forwarded to all of them in the group. All of them will all receive the request coming from the listener. And this is where we'll see where this target group is linked to our target. Okay. So after that, after we have created this load balancer, we have created a NAT gateway, we have created an internet gateway. Then the next thing to create is, of course, our target. And to create our target is part of our Elastic Container Service, ECS. The idea is this: ECS can either be in form of EC2 using server, or can be serverless. So Elastic Container Service can use two tools or 2 ways to provision containers. Yeah, let me say 2 ways. The number 1 way is using a server, and in that case, we'll be spinning up an EC2 server. Another case is using serverless, like not using a server. And whenever it is serverless, it means we are using Fargate. Fargate is the name given to the serverless form of creating container. So, and for this project, we are using serverless. So that's the reason why we are using Fargate. So to create a serverless, whether it's receiving server or serverless, we need a resource that is called ECS tags definition. What ECS tags definition does is that it's the one that creates the container. That is where the containers are actually created. And this is where you will know, earlier on I was saying something about a particular Terraform script is 1 container, another one is 2 containers. This is where you see it. So see, container definition is inside this resource. This is where you define the container that you are creating. Are you creating 1 container? You use 1 image here. This from here to here is 1 container, because it's using just the name of the image. Look at it. This is another name of image. See, image name. This is another container. So if you want to create 3 containers, I'll put a comma here and do another of this. That will create 3 containers, because I'm just having 2 of these. This is 1 container from here to here. This is another container from here to here. So the number of containers you want will determine the number of this group from here, on this image, memory reservation, CPU, the name of the container, and the port mapping, the container port to the host port. And that's it. And we are done with creating our container. But, just like a load balancer, Elastic Container Service uses security group to, just maybe the whole essence of security group is to limit the traffic. We don't just want any out traffic to get to our resource. We want to streamline it, we want to filter that traffic. We don't just want any Dick and Harry to have access to my resource. So we attach a security group to our Fargate so that, looking at this diagram, it is only the traffic that emanates from our load balancer that will go in. Any other traffic, if the traffic is coming directly from the internet, it won't go in, because we will not open the port to internet here. We only open the port that will be open here for our Fargate is the port that is opened here from our application load balancer. So it's like saying the exit port here on our application load balancer will be the entry port on our Fargate. The exit port here will be the entry port, so that we'll know that, okay, I'm expecting traffic from the port that is open on the application load balancer. So that is what the security group is doing. Now look at it. On the security group, the only port that is open is what? 88. Why did we open 88? Because that is the exit port on our load balancer. How do we know the exit port on our load balancer? Look at the listener. We'll say the listener forwards the request to a target group. So we now go to the target group and say, okay, what port is open on the target group? Now look at it. What port is open on the target group? This target group. What port is open there? 88. And it is on this target group that our Fargate is attached. So Fargate will be expecting a request from 88. Because that's the port it is attached to. Fargate is attached to the target group. So the reason why we only open port 88. That's all. That's the only port we need. We don't need to open too many things. And of course, just like in the case of load balancer, when we are creating Elastic Container Service, I want this to be at the back of our mind. Elastic Container Service, when we are creating that resource, it comes with, just like a load balancer, like 2 additional resources, plus the security group, making it 3. In the case of load balancer too, we have 2 additional resources that makes the load balancer a complete resource. Then with the addition of the security group, it makes it 3. So so we can just say that an application load balancer requires 3 resources to make it a complete resource. It requires the resource to create the application load balancer itself, 1, the resource to create security group for the application load balancer, that is 2, the resource to create a listener that listens to incoming traffic into the application load balancer, making it 3, then the resource that creates a target group, making it 4. That is for the load balancer. And the same goes for the Elastic Container Service 4. The first one will be to give name to the service that we are creating, that Elastic Container Service. We will give it a name, and that is what Elastic ECS cluster is doing. We're giving it a name. Elastic Container Cluster. So you create this resource. When you create this resource, you need 3 additional resources to make it full. One of the additional resources is the security group. That is 1. The next one is the tax definition. You can see ECS tax definition. That is 2. The last one is what we call the ECS service, and that is 3. That is all. We are done. So it's something we can just memorize. Three resources are needed. When I'm using an application load balancer, there must be 3 resources added to the application load balancer resource itself. The same thing with Elastic Container Service. With the Elastic Container Service itself, 3 additional resources must be created, and the 3 additional resources are like the Elastic Cluster, the security group, and the security and the tax definition. So that's kind of straightforward. In the Elastic Container Service, that is where we state the launch type. This can be Fargate or instance. So if we don't put Fargate here, we put instance here. Put instance here, it shows how we are using a server kind of container. But in this case, we are using a serverless container creation. So Fargate, it could be Fargate or instance. And every other thing is, they are pretty spelled out in the template. You go on the Terraform script template, you see the network configuration. And this is where, look at it, this is where the load balancer target group and the our Elastic Container Service, they are attached together, our target. You can see the load balancer requires a target group RN. And when we put the target group RN here, that's the target group ID and the container name and the port. Then we have tied our Fargate to, where are we tying our Fargate to a target group of the load balance. So that's all. If we understand this concept, that's all we need. We are done with Elastic Container Service. We are done with Elastic Container Service. So what I will do here is I will just edit. Let's edit it so that we understand what we are doing. We are good with AWS, the PPC, the subnet, the routing. There's nothing to edit there.
Oh, excuse me, 1 minute, brother.
Yeah.
Sorry. Are we using a public VPC or a default VPC rather?
No, we are not using.
Yeah, because I'm trying to follow it. I was thinking, because I was looking at it, it keeps saying it wasn't showing like we specified it from the start. I don't know, maybe I'm a little bit confused about that.
Oh, okay. Yeah, let me show you. We are creating a custom VPC, like a customized, the one we customize. So it's not default. So the custom VPC is this. This is why that's the very first thing we created. Oh, this may throw you off. We call it default. It's not a default VPC. Hold on. We're calling it default here. Let me call it that may be.
Yeah, that was what I get. That was what threw me off balance, because everything down to have default.
No,
that was what I kept.
See, this is what if we are using a default VPC to be here. Instead of AWS _ VPC, you see default.
I got it, screwed up.
So this one is a name. This one you can give it any name. This one you can give it any name. But this one you can't give it any name. The resource type, you can't give it any name. It is the name that is stated in the Terraform documentation that must be here. That's the resource type. As you can see, it's from HashiCorp. But this one is your own reference name. You can give any reference name you want, just like the way I'm looking custom. I can do this custom VPC. So I've named my VPC custom. Don't mind, this is the naming. So here, everywhere I'll be referencing it to custom. It's a name, custom VPC. It's a name. I just give it a name. But this one, so if we are using a default VPC, like I said, it is here that you will know. If default is not here, it's not part of the resource name, you know that we are not using default VPC. But let's go there so that it will be clearer. If we look at our Terraform documentation, if we go to VPC, this is virtual private cloud VPC. See, AWS _ default, and this is for the subnet. Let me look for the VPC. You see default as part of the VPC. No, let me see. VPC. Okay, resource C. Default, there will be default C, AWS _ default VPC. So when we click on it, so when it has default like this, it shows that we are using we are not creating our own custom VPC. We are using the one that.
So we are using the one they gave to us from here.
Yeah, from AWS. The one AWS has created in the region. When we use this kind of resource, it means we are using the default VPC AWS has created in the region. So, but if you don't see default as part, like if I scroll down, okay, if I go to the other VPC, the one without default, let me see. VPC without default AWS. It's like this one here. This one here, if I click on it, you look at this one does not have default here. So this is a customized VPC. It's the one I'm creating newly with my cider block. And you can even see this one, cider block, is stated. Let's look at the default one. Default one, you don't even know the cider block because you are not the one creating it. The default here, the default VPC. Look at it. You are not the one creating it. You can't stage the cider block because it has already been created by AWS, and you don't even know the cider block that AWS used to create it, except you go into the management console and start searching for it. So you can't even state the cider. What you can do is just change the name and do some other little things, So, but the custom VPC you are creating, you will be the one to state the cider block you want to use for that VPC. You will create the cider block. This cider block is like an IP address. You are giving it an IP address. So this is the range of IP addresses that should be able to access my VPC. So that's the difference. So I changed the name to custom VPC. So that will make sense. That will, yeah. And that's even better. So VPC ID is a custom VPC. VPC ID is custom, is customized. I'll just watch out and make sure I change everywhere the VPC ID is being used. So like here to VPC ID. So it's not the, it's a custom VPC. Custom VPC we are using. Okay. Here too, we're using custom VPC. Where custom VPC. Okay. Here too, it is custom VPC. All the places where VPC is being referenced, you must make sure we put the right thing. Like here, we have changed it to custom VPC. Just a name, just like the way they are calling this one, load balancer, but it's a name you can decide to call it any. So, but to make it clear, that we use a name that is not confusing the default resource. So, custom VPC, good. Anyway, let me check all the places where VPC has been referenced. Yeah, I will change it all at once. This also custom VPC. Okay. Okay. So there's my VPC and VPC. I think that's good. If there's an error, to let us know. So another thing we need to change here is, look at here. When we were creating our container, we give it the name of the image, the Docker image. But in this case, the image we have pushed to our registry that we want to build the container from. So here in the AWS part definition, look at here, this is where we are creating our this is where we're creating our containers from. So look at here, this image name must be the one on our container registry. So we go to the container registry and get the image name. So use the container registry here. So use our backend. So if I go to the repository, you see this is our DevOps package. So this is the URI to the image. So we copy this, copy the DevOps backend, formula, and paste it here so that we are telling it to go to that place and fetch that particular image, Control D. So, but don't forget that whenever we put the image, we must also put the tag to the image. So the tag can be latest or whatever you have with the tag. So if I go back to this image here, you see that the backend has a tag. All the tag, the image tag is 5. So we must put 5 there. Don't forget that tag. It's important. Without the tag, there will be an error. Right? So we have changed this, and you can decide to change. This doesn't matter. You can call it our DevOps, the name of our containers, whatever name you give it, you give to DevOps backend app is the DevOps backend. And we map the container. This container port, remember we have opened it in our Docker file. Is the one we open here in our Docker file. We go to the repository, this repository. We go to our backend Docker file. So look at the Docker file. We expose it as a container port. Give me a minute, guys. That is exposed on our backend, and that is the port we are using. You can see the port on our backend. That's the container port, and we are mapping it to the port on the host. This host port can be any port. It's not compulsory to be 8080, but just for convenience sake, so that we don't start remembering what port am I mapping 8080 to on my host. But if we know the container port, we know that we are mapping it with the same port. So that's the reason why we're using the same port on the host. This port can be anything, just like the way we were taught in Docker. So we can map it to anything on the host port, it doesn't matter. So and the front end too, you can see this is the front end here. So we get the image name from the front end. We go to our front end repo. Now this go to the repos here. This is our front end, and this is the URI here. So use this URI to fetch the image on that front end. You can give our container name any name, just like to make it sequence with say DevOps front end hack. Can be any name. You can call it AD1, AD2, it doesn't matter. But the container port must be the same port that has been exposed on the Docker file when we were creating our image, our front end image. So if we go there real quick and confirm, say, okay, on our front end, though, in the Docker file that we use in creating the image, what port did we expose, did we open? So if I go back, front end, I click on front end, go to the Docker file that we use in creating the image. So, okay, we expose 3000. Okay, so our container is running on 3000. So let's map that 3000 to the host machine that the container is running on. So we have mapped it also to 3000. We can decide to map this container port to any number, say 1000. So it doesn't matter, but for convenience sake, so that we don't have to remember what number that are the same number together. So that's that. So this has been taken care of. So, but there's a concept I want to point out to us. You see, this particular project that has front end and back end, it's like a web application. You know, a web application has front end and back end. The front end is where the user, like if you are, okay, this is what I want to see. So if I open a browser like this browser, what you are seeing right now, this GitHub that you are seeing. You are seeing the front end of the GitHub application. There's a back end that we can't see. The back end is whenever I click on this, for example, if I click on code, DevOps code challenge, I just click on it. This clicking is sending a request to the back end. So the back end will now process that request. So when the back end processes the back end understands, okay, a DevOps code challenge has been clicked. I need to send the repo to the front end. So if I click on this DevOps challenge like this, the backend will send the content of the repo. So the backend is sending this. If the backend doesn't send this, I won't see it. So it's the result of the backend that the front end is displaying. So for example, if I come here and I click here and I click repo, when I click this repo, it will send a request to the backend. When the backend gets this request, the backend understands the repo request. So, okay, whenever a repo, somebody has programmed it that whenever you see a repo clicked, send to the front end the list of the repos in my database. Because the backend uses a database. That usually a database is connected to the backend application. So it will say, okay, go to the back or to the database and fetch all the repos that have been stored in the database. So that is usually what you click a repository like this. The backend will quickly process it and send the result and list all the repos like this. So that's how it works. Okay, but that's a conventional front end and back end relationship. That's the usual front end and back end relationship. But there's another front end and back end relationship that does not have a user interface like this. That a user cannot be clicking places. That is the type we are working with in this project. The reason how did I know that there's no user interface? Because there is no static file. There's no static file. There's no .html. The .html, that is what we are seeing here. There's a static file that we are seeing that we are interacting with. This is a static file that has been put. But in the project we are working on, we go back to that project, this DevOps challenge project. There is no .html that we are working on like that. This is the front end. If I look at the front end, so the front end just only has index.css and JavaScript. There's no .html page. If it has a .html page, then we'll have something like this that we can be clicking on to be sending requests to the backend. The only way we send the request to the backend in this type of application is through the browser by putting the command here. Now, let me now shock you. These things, they are connected. In this type of conventional front-end and back-end, this GitHub page that we are looking, this is the regular conventional front-end and back-end relationship. Whenever we click that has a static .html page where the user can interact. When the user is clicking any place here, it will be sending requests to the backend. What is actually, when I click on DevOps challenge, what is actually going on is that my URL here will change and we have DevOps code challenge as part of it. It won't end here. See, this one is having /src because I'm in src. If I click on DevOps, it will have only /DevOps. Okay, let's see. If I click on So you can see it stops at /DevOps. So it's the same way. This is just a convenient way for somebody who is not a tech person to interact with the backend, like all this market woman, or this a non-technical person, maybe somebody that has a accounting background, a business background, a non-IT background, to interact with website or so they created a user interface. They call it a user interface. This page where the user can click on buttons. But in essence, when the user click on button, what is happening is that that button is changed to a URL that is sent to the backend. For example, if I click on a button this button now, like this backend button, if I click on it, you will see backend will be added to this. It will do /backend. Okay, let's see. If I click on it, backend, you see the /backend. So it is this that is sent to the backend as request. But for somebody who is not technical, who is not IT oriented, will not know. I'm just clicking button and it's giving me a result. If I click Gitpod now, it will take me to Gitpod. But what is actually happening is that a Gitpod command has been sent to the backend. That is what is actually happening. But that's just by the way. So why did I bring this up? It's for us to understand the project, that the project does not have a front-end page like this, but it has something we can always send the request to through the URL. And that is, the URL is what we need to get whatever the backend is bringing. We need a URL to send request to the backend. So when we send request to the backend sends a reply. So when the backend sends reply, the reply will be displayed on the browser. To display on the browser. Okay, that's why you understand why I went into this explanation. So this is done. This is good. So this is the reason why I went into the explanation. See, the load balancer here. If you look at this architectural design, somebody from the internet will send a request. When the person sends a request, the request goes through the internet gateway. From the internet gateway, it gets to the load balancer. Should the load balancer forward from the explanation I just made now, then you can ask, should the load balancer forward the request to front end or back end? Of course, from the explanation I just made, the load balancer should forward the request to the back end, because we don't have a static page. The person that is sending the request is not sending the request through a static page, like a user interface. It's sending it from the internet through a browser. So it's not like he's clicking a button. So this request will go from the load balancer to the backend. So when the backend gets the request from the load balancer, the backend sends the request out to the NAT gateway back to the person that sends the request. Where is the person sending? What is the person using to send the request? The person is using a browser. So then the result will be displayed on the same browser the person used to send the request. Okay. So the reason why I'm saying that is, look at this place. The load balancer must send the container name that the load balancer must be connected to is the backend container name. So this one should be the name of our backend container. If this container name is the name we give to our backend here, these are frontend name, DevOps frontend app, but these are backend name, DevOps backend app. So that's the reason why I'm using in the load balancer here. I'm using the container name I'm not using the one from the front end because we don't have business with the front end. The request, the load balancer is sending requests to the back end. So the load balancer sends the request to the container name that is the back end. Now, what's the port of the container at the back? It's 8080. The front end is the one on 3000. So this one is on 8080. And that's it, guys. So the variable is the variable is just like what Mr. Yomi told us about using variable to make our script kind of flexible. So I'm incorporating variable here for count. And where did we use this variable count? You see, I think we used it in under this tax definition here. We said it should create let's see. We use that variable somewhere val from I think it's let me see load balance. So this is ECS, yeah. Desired count. The desired count of our service should be one. Just one service to run. So service is the name that is given to the group of containers that are running. So okay, if you have you can have 2 containers running in one service. So if you have more than one service, then that means you are duplicating your containers. So that's the reason why we just the desired count we want is one. But if we want more for higher availability, so that if one service goes down, the other one can still be working. We can make it 2. So we are using one. That's the and we are using a variable for the naming here. So say this is the default name is what's called this the DevOps code challenge. So and you know usually if we want to check what we are doing, we use the IP address. The IP address of what? Of the server we are trying to access. We use the IP address of that server colon the port number. But in this case, we are not interfacing with the server directly. We are using a load balancer to connect to that server. And in this case, it's not even a server, it's a serverless application. We're using Fargate. So we're using load balancer to connect from the architectural diagram. A load balancer is interfacing with the Fargate. So instead of we can't get the IP we will have gotten to use here is the elastic internet interface IP. But since an application load balancer is interfacing with this network interface, instead of using the IP of the network interface, we just use the DNS name. It's the same thing anyways. We can decide to use this or this. It will give us the same result. We use the DNS name of the application load balancer or the IP address of our Elastic network interface. Then if we are using the Elastic, the IP address of our Elastic, that means we will need to do column with the port number. But if you are using the DNS name, the DNS name of the application load balancer has the port number already incorporated with it. So all we just need to do is get the DNS name of the load balancer and put it on our browser, and we'll see the result. That's the reason why we are outputting it. The output resource, so to say, to get the AWS load balancer DNS name. So DNS is a domain name service. It's used in place of IP address. From my research, okay, let me just explain that a little bit. So before we run this script, for example, if we run just to grant our understanding of DNS, if we do www.google.com, what this means is this www, we are using the DNS of Google. The DNS of Google. If I don't want to use DNS of Google, I can decide to use IP address of Google. How do I know IP address of Google? Look at this. Instead of saying, this takes me to Google website. But instead, I can say, if I say Google IP, if I look Google IP, so Google is using this IP, 8.8.8.8. So instead of typing www.google, if I do 8.8.8.8 colon 443, that's HTTPS, right? Oh, 443 is not working. Oh, okay, it's using HTTP. HTTP, that would be 80. If this IP address is good for Google, it will take me to Google. If it's not good, I think they have many IP address. Well, Google has many servers.
Yeah, that's what I want to check in. But so, if you want to know the IP address that you have in your location right now, just go to the command prompt, then ping. Go to your command prompt, please. Okay. Just go to your your terminal. No, your main terminal, your system terminal.
Oh, okay. CMD.
Doc CMD, yes. Command prompt. Yeah. Now ping ping. Just write ping www.google.com. And that's the IP.
So reply from this is an IP6 giving me IP
that's so you can see that you won't be able to guess it if you are using guess. That's the IP address that Google is using to broadcast in your location. And you can see it didn't drop packet at all. All of them just.
It's using IP version 6. If I can get the version 4, it will be really. Let me see.
You can, if you copy the IP, I think you put it on Google now. It should work.
Oh, okay.
Let's see what we have.
Copy. Also, I know people uses. I know this is IP version 6, but if it gives me IP version 4, it will work just like you said. But this versions, IP version 6, let me see.
I'm actually surprised giving us version 6.
Yeah,
Back then at home, if I would just want to know the IP address, I would just, and it's still going to bring it.
yeah, it's true. I've seen the version 4 to this thing. The thing 8.8.8.8 version 4. It's actually replying back.
It's replying, but the problem is, what happened.
I know they are kind of tied together at the back.
But what happened here is that it's not going to display that one. It didn't even drop packets. They're going very well, but it didn't. You can see lost 0. No packet is dropped. It's dropped. You sent 4, it received 4, lost 0. And what happened here is the IP is right, but
it's not the one that is serving.
It's not the one that is serving here.
Yeah.
You understand? So you can ping it, but it's not serving it. It's not the one that is serving your location.
Yes. That's true. That's true. I know they have many.
You're just explaining what do you call this thing that you just explained now? I used to call it failover.
Load balancer.
Load balancer, yeah.
Mm.
So it's going to give you whatever you want as long as you want it, but it's not going to. Please, you can continue. I'm sorry for.
Oh yeah, it's okay. So what I was just trying to say is that the DNS is just an equivalent of the IP address. If you know an IP address of something, in fact, what brought about the issue of DNS, the domain name server, is because it's because of us human beings. It's kind of difficult for us to remember IP addresses because of the number. How many number you want to put in our head? But it's kind of easier for us to remember names like www.google.com. So they now say, okay, instead of saying, if I want to go to Google website, I should type Google IP address, port number. Why don't you just type www.google.com? So that's what brought about DNS. So DNS is a way of making it easier on us human beings to access a particular website. And that's what we are employing here with the load balancer. If we know instead of going to our browser and be typing IP address, we just put the DNS name of the load balancer. So that takes care of that. So I'll just run over this script again to see if everything is good. So we have the load balancer, we have the backend connected to the load balancer. The network is good. It's on our target is on our private network, subnet. Yes, we are using Fargate and the cluster, all this is good. All this, well, we can, yeah, this is good. Name is just anything. Custom VPC, we changed it. Yeah, that's good. Our containers are good. This is not good. Our front end, honestly, this will have failed because this does not have a tag. We must put a tag there. When we are with our image name, we must always put the tag that the image is. Sometimes it will be latest. The latest will put latest, but here I'm using build number. I decided to use build number just to track the number of build that we have done. So that's it.
So the front end and the back end has the same tag number then? Is that what you said?
Yeah, because they are built together. They are built on the same Jenkins server. They have the same tag. We can check it. It's here. right here, the container registry. This is the front end. If you click on the front end, the DevOps front end, you see the tag. The tag is 5. So the tag is the build number, and it is gotten from here. We go to the Jenkins file we use in building the whole image, the whole process. The Jenkins file we use to automate the whole process. So you click on the Jenkins file. You see we attach a build number. So if you do build 1, you know, when we're building build 1 field, we had an error. Build 2 field, the build number 2 field, build number 3 field. There was an error with build number 4. It was build number 5 that succeeded till the end. That's the reason why we have 5 here. So
is it not from Docker file you looked at it previously or what? Is it not from Docker file you checked it? Because I remember when you went to Docker file to check the number earlier on.
Okay.
Because now it's on Jenkins, you are checking it.
Yeah, the number I checked on Docker file is the port. Let me look at it.
Okay. Because I know you checked you went
to the front end, the Docker file here. The only number contained on the port exposed the port. But the build, we use Jenkins to build the steps. You remember, it's Jenkins we use in building artifacts.
Yeah, definitely.
This is for image. So it is the build number we are talking about here is the number of build that we did in Jenkins. The first build, the second build, the third build. It's just that we have destroyed the Jenkins. Oh, okay. I can even let me open. Sudo service Jenkins start. So I've started a local Jenkins. It's not the one we use actually, but it's just a local one, just to show, just to bring that to our memorial Jenkins. So if I do localhost 8080 to open my local Jenkins, localhost Jenkins. You see that we have different build numbers depending on the build we are doing in Jenkins. Okay, good. So if I take, for example, if I just take one of these projects, oh, this one is just one build. You can see this is the number of build. But this is kind of a strange one that I just build once and everything built correctly. There are ones that let me see, like this one that has this one too. Wait. I think those ones are the ones I have perfected very well. Like this, you see, the build one didn't succeed, and this number is the one that is being attached to this is what we call the build number. So I think there are several ones that has multiple like this. See, we built it 9 times. See, 10 times, 13 times. It was the 13th one that was successful there about. If I click on it. Alpha 2. You see, okay, there are several successful ones, there are several failed ones. So this number 13 is the build number. It's the one that is, finally pushed to the repository. So that's where the big number. So this is inside Jenkins. That's why we are looking at the Jenkins file. It's Jenkins that controls the build number. Jenkins that has the build number. So it's the one that assigns the number. Jenkins assigns the number depending on the build. Click on another build to assign another build number. You click on this build now to assign another build number. Start continuing from where it stops to assign 14. So Jenkins controls the build number. So the reason why we are looking at Jenkins file, not the document. So yeah, that's the image. We cut that. That is pretty. That's everything. So if I go back to, yeah, I should be working. But I should be working here. I should be working on YouTube. So I'll clear here. Clear. I need to run. The first thing I need to run is I need to connect to my AWS account by doing AWS configure. The reason why I'm doing this is because I didn't put the default, the access key here and the secret key. If I had put the access key and the secret key here, I won't have to do AWS configure. What? Because the access key here will have logged into AWS automatically, but because I didn't put it here, I need to manually key it in my terminal. So I do AWS configure to ask for my AWS access key. There is one already there. So there's a user access key. I think it's good. That one is good. I will leave it. The secret 2 is good. I will leave it. US is 2. That's where I want to deploy to. JSON. Okay. I think there's an access key that has been put there. Had it been there is none here, I will go to a user, or I'll just look for a user that have downloaded the access key in the Excel sheet. There's an Excel sheet. Yeah, this one here. Yeah, I will have just copied this, the access key and the secret access key, put here. But since I have one here, I think it's good. Well, I can even, yeah, it's good. So there's no point copying another one. Well, to be sure we are okay, let me do this. AWS configure. Let me copy the one I actually used for this project. This one here. Copy. Sending with G2. Yeah, G2 enter. The secret access key. Let me copy this one here. Copy. Sending with G3. Yeah, G3. Enter. Region should be used to. JSON still should be used to. So we have put this particular access key in there. So let's go back to our lightfeather platform and just run this. So let me clear the screen. Do Terraform init. So while this is initializing, let me quickly show us our my ECS here, Elastic Container Service. This is the Elastic Container Service where we are going to create our containers. So we want to check there now and see what is there, if at all there's anything in that place. Elastic Container. So if there's any container that is running, or but that is just to check. It's not going to affect our deployment anyways, but just to check. But this is in not Virginia, so we're gonna need to let it load. New experience, okay. So if I look at the cluster, I see there's nothing. Well, this is not Virginia. Let me change it to Ohio. So that's list 2. We're using list 2 anyway. List 2 US is to Ohio. Stay in Ohio and see what's good. See, there's no cluster running. There's no tax definition. The tax definition is where the containers were defined. There's no tax definition. Okay, so let's go get our script going. So we have initialized. Let me clear the screen. Let me validate the script and to be sure that the script is valid for deployment. Terraform validate. I didn't see this one. Default and this good. You see the reason why. So I'll start from 39. 39. I didn't see the, I changed 39. Imagine this one should be custom VPs. Custom VPs. Good. I saw another one, 50 and 66. 50. You see, the eyes cannot catch everything. This one should be dots. Custom VPs. I saw something else. For the 66. Custom VPs. 66. So this one should be route stable. So another, and this should be custom VP. It's not good to run this and Terraform validate for me just to be okay. I think 66, that's all. Let me clear the screen and validate the form again. The scripts. You say the configuration is valid. Okay, let's do Terraform plan. Okay. 2 problems are you saying? Okay, it's talking about this business. Okay, set configuration. Oh. Yeah. tag this shoe. What's the company level? What's wrong with level? This tag. It's saying with the provider details. Getting ID code. What's the complaint about? The security token included in the request is invalid. Have I deleted it? The security token. What happened with the security token? Hold on. Access key. Where's the access key used? Except I've messed up with the access. Okay, this is what I'm gonna do. Let me open the file real quick from the desktop. This is the copy from here. Wait. Is it the one I'm supposed to be using? What's it like for them? Desktop. Lightfeather project. Okay, so copy. Okay. Yes, it's two. Yeah. I'm going to have from AWS provider error validating provider credentials. So seeing that my credentials good. So if it's complaining about this again, I will need to go and use another IAM credential. So maybe I've tampered with this one somehow.
Wait, the credentials don't expire, right?
No.
But you can create multiple credentials, but you have to know which one you're using at this particular time, isn't it?
Yeah. You have to know the one you're using to create your resources. No, it's still complaining about other. So it's saying configuring AWS for error validating provider credentials, retrieving caller ID, and I don't even know the name of this. Okay, hold on. Let me go to the user, to my IAM user, the one we created. We use in creating this the image. I think we which one? I think we created what's the name again? It would be like I think I've deleted some. This 21 days ago, 6 days ago. I think it's this one. Maybe 6 days ago that one mistake. 6 days ago. Yeah. Yesterday. Yeah. I think it's this one. Code challenge. This is the one I use. I want to be good. Okay. Is the one I use. Let me see. Let me generate this. This one. This access to access. Can I do it, or should I create another user? Let me do this. Let me add username now. Let's call it now. Next. I want to know what's administrative access policy. Next. Create a user called now. Click on the user. Go to security credentials. To create access key. Give a command line. You understand. To do more. Create access. Copy this. Put it on AWS. Like this. AWS. I think I've deleted the user I created with this one, the lights. Yeah, I deleted the lightfeather user. That's the reason why it's confused. I can't even see it among my users. Anyway, now I have a user. I deleted the user. I can't remember if I did. So we have the plan. Then let's apply Terraform apply, auto approve, yeah. I remember we call it lightfeather user. That's the name we call it. I can't see lightfeather user. I deleted it. I think that's the problem. I go to user, there's no lightfeather user. Okay. I remember I actually deleted some user some like 2 days ago, but I thought I wanted to delete this project use. Yeah. This one I wanted to delete, but I deleted the wrong. I wanted to delete this project use. I remember I was supposed to delete the one I used yesterday. But I deleted the wrong one. This one, this one too. Okay, so let's see.
So was it because you deleted the project when you did it at first, or why? Well,
no, what happened is the error is like when the error came out, we read the error. The error is complaining about credentials. So I know that it's talking about, and it's pointing to, he said AWS credential. The only thing that uses credential in AWS is IAM user. So that's the reason why I kind of pinpointed down to, it must be my IAM user access key and secret access. So that's why I went back to check for the user, for the secret access key. I was using this one here that we use for our Jenkins, but I've deleted it. If I deleted it, then they are not valid again. So it's actually called lightfeather user. So I think I deleted this light because it's not among my users when I check now. It's not among my users. So, and I was using you can say I used the access key and the secret access key that has been deleted. So he couldn't find the user again. So he's saying the credentials are not valid. So I had to create a new user with a valid, where I got the new access key and secret access key. And I put it there and it worked. So the problem, the thing is for us to read the error and kind of understand what the error is saying. So, okay, the clue would be in the error. It will complain of invalid AWS credential. Okay, the only place I'm using credential here is AWS config, where I put the IAM access key and the secret key. So I just went there and create another user so I can get a new access key and a new secret access. So this is gone. This is not valid. So I deleted. I remember I actually deleted access key yesterday or day before yesterday, but I deleted the wrong one. I deleted the wrong because I thought the one I deleted I thought was exposed already. Well, I can't deleted it. Okay, our resources is done. If we go back to our what's it called now? Our ECS, Elastic Container Service, which is find our containers running, the 2 containers we just deployed here. Okay, spending. So let's wait for it to start running. I will refresh. Okay, it's not running. So if I click on it, you see the services, we have one service. Under service, you have our container running. Okay, we have this task, one task running, completed. Okay, under task, we go to under task, we find our container, we click on this, find, click on this, task definition, we find two containers, and they are live. Okay, so we have this DevOps, this is the name we give to our container. You can see container name. So these are the name, the one we give to their tag, these are their image. So we have this. How do we access the container that is running? You can see it's here. That was the reason why I was explaining the DNS thing. It's here. The load balancer IP. You can see it's an equivalent of the IP address. It's a load balancer IP. That's the DNS. We copy the DNS. You know, we stated this in the output and it outputted it for us here. So copy it and go to our browser. Okay. And try to send that request to our backend. So this thing I'm pasting here, it's like I'm sending request to a backend. It's like I'm clicking a button. So this is going to backend. So backend will send a reply. So the reply we're expecting to get is an ID. And that is it. So the backend, this is the front end that is displaying what the backend has sent. So this, what we are seeing here is the rendition of the front end. How do I say? Is the rendition of the back end in the front end. And another way of saying that is saying that is the representation of the result from the back end by the front end. So the front end is what I'm looking at. But these results, all these things, is coming from the back end. It's coming from the back end. So guys, that's it. We are done with this project. Okay, that is all about the project. We have used this Terraform script. Yeah, lightfeather. But yeah, this all we need. Everything is just one file because it's not a long script. We can try to break them into separate files, you know, for the sake of simplicity and just having them in one place. It's to put our provider together with our main.tf, together with our variables.tf. These are variable.tf, together with our output.tf. Everything modeled into one file.
So if we omit, sorry, these options now, if we omit this one that says variable and the other one, I think the one up one is string, like this one. The two variables. Yeah. If we omit the both of them, it won't run, right?
That means we won't use them in the script. If we don't use them in the script, it will still run. So all these places where I have variable, like this place, var, this var is using the variable app underscore count. You can see var.app underscore count. So instead of using this, I will use one. I will just put one here. Because that's what it's representing. That's what var underscore app. That's what var.app underscore count is doing. It's
so that's why it has numbers.
Yeah. So it's a number type, and the default is 1. So if I put 2 here, that means I'm using 2. I'll put 2 here. So if you don't want to use variable, then you'll be putting the number by yourself. Add coding. That's what they call add coding. but it's not advisable to hard code. But hard coding is kind of difficult to edit hard coding because you'll be going to everywhere. Just like what I did with the VPC. And you see the way I was going everywhere to change the name, and I still missed out some areas. But if I didn't hard code, if I had used variable for that part, I would have just come here, a place, just one place, I will change it and it will change everywhere. So I'm going to, where did I use VPC dot this thing? Where did I use? So I will have just come here. So that's the reason of using variable. It's easy to edit. I'll just come here, edit this, probably this one alone. And everywhere I've used variable will be changed automatically. So that's the beauty of using variable. It's good to edit your code, to debug your code. It will be easier, it will be faster, it will be quicker. So it will still work, but you need to hard code it to still work. All right, so we have the scripts, we have this video, and we should be good, guys. We should be good. There's something I will just share with us on the platform. Something I got on one Discord group I'm on, and it's all about interview questions for DevOps. So here are interview questions asked during 4 to 5 interviews who attended. I think of someone who attended cloud engineer and DevOps engineer interview here in the UK. Somebody posted it there. So these are the kind of questions they asked the person. What is X3? Types of load balancer, difference between virtualization, Docker, and hypervisor. Right, so what's our 53? You know, this I'll share with us in the group. I'll share the files. And that's it. Before AWS chop my money, let me destroy. I may even forget. So they have chopped enough of the money, so let me destroy.